So today we get to talk about solutions and mixtures. So let's define what this is. Technically speaking, a mixture is any time when you take two or more pure substances and you combine them together. And there's two versions of a mixture that you could be dealing with. You could have a homogeneous mixture whereby the multiple pure substances that have been combined together are yielding a solution that only has one phase. To you will not be able to tell there's multiple things present in here because only a single phase will be present. And then there are those mixtures regarded as heterogeneous, where you can actually see multiple phases present. Typical example, oil and water. You will see the oil layer sitting on top of the water layer, and you'll see a clear separation between the two layers, depicting the presence of multiple layers in the first place. And that alone makes the solution be heterogeneous. And this particular feature need not be allocated to simple liquids. The presence of a solid with a liquid and the solid is not in the liquid, that would be another heterogeneous example. Now, we're going to be focusing almost entirely on the homogeneous mixtures in this class, but heterogeneous mixtures do have and do play a huge role in industry in the process of preparing molecules such as fertilizers or even pharmaceutical molecules. So they're actually very useful, but we're going to concentrate on the homogeneous cases, which are a little bit easier to handle and understand from a simple point of view. All right, now a few terms that we need to establish in terms of definitions. Homogeneous mixtures, you will refer to a solution, and the solution itself is going to be the combo of two things. One of them is the solute, and this is the substance that is present in the smallest amount. And by smallest amount, I mean the amount in moles, not grams, not volume, but actually moles. So, for instance, let's say you had sodium chloride, so salt water. The sodium chloride will be the solute in the solution. And if you calculate the number of moles, you're going to find out that it is less than the number of moles of water. So the substance in which the solute dissolves in, that's what we call the solvent. But you could also look at it from the point of view that it will be the substance present in the greatest amount between the two. And just to kind of show you in an exaggerated way, this is all the water molecules surrounding your solute. So you have a lot more of them than you do have solute. But solute plus solvent equals solution. We're going to rely on that idea to solve some of the concentrations that I will be establishing, in a few minutes from now. All right, now concentration. This is how we're going to be able to tell how much of a solute there is present in solution. And generally, the way we depict this ratio, this amount, is by dividing the amount of solute by the amount of solution. Generally speaking, that's what most of the concentrations we're going to talk about in this class will come down to. Some amount of solute over some amount of solution. And as you'll see, depending on the specific concentration, we'll be talking about the amount could be in grams, the amount could be in moles, the amount could be even in volume. There is 4 in particular that I want to pinpoint out right now, specifically molarity, percent by mass, percent of mass per volume, and the mole fraction. All of them will have some amount of solute on top, and they will have amount of solution on the bottom. But then there is one specific concentration that's a little bit different. It still has amount of solute on top, but on the bottom, we're not going to have the amount of solvent. Specifically, this is called the molality. And I'll show you how to calculate them and what the actual denominations for the amounts are. Alright, but the other thing I want to point out right now is that since concentration is the ratio of two different things, technically speaking, concentration in and of itself is a conversion factor. A conversion factor that could allow you to switch over from amount of solute to amount of solution, or vice versa, from amount of solute to amount of solvent, depending on what kind of concentration you have. Alright, so what I want to introduce right here is something that I dubbed the Mudoku tables. Think of this as being a Sudoku table, but for concentration. And the table, as you can see here, is basically divided into 3 rows. You have the solute, the solvent, and the solution rows. And then you have these 3 columns. The ones that are probably the most relevant and important for the vast majority of the entries are the mass and moles columns. But you're going to have one in addition, which is the volume column, which technically is going to only pertain to the solution, at least for most of the things we'll be looking at here. Alright, now here are the things that you have to keep in mind. In terms of switching over from mass to moles, you can do this directly for the solute and the solvent. But that conversion cannot be done with the mass and the moles of the solution. That direct conversion you cannot do. I'll show you the way in which you can actually go from mass to moles, but it will not be direct. The one thing that you can do, however, is switch between the mass of the solution and the volume of the solution. This will, in essence, mean that you have to have the density of the solution present. Alright, so from mass to volume for the solution, you can do that. Mass to moles, it's going to be a little bit more tricky than it looks like. So right now, direct conversions, not direct conversions for solution. For solute and solvent, however, the mass to moles conversion is definitely allowed, and it can happen. Now, in order to address the issue of the solution, what we have to keep in mind is that solute plus solvent equals solution. And this applies to mass, and it does apply to moles. So we can actually write 2 equations relating to that relationship. The mass of the solute plus the mass of the solvent equals the mass of the solution. And by the same logic, the moles of the solute plus the moles of the solvent equals the moles of the solution. The one thing I want you to be careful not to make a mistake about is that although solute plus solvent equals solution applies to mass and applies to moles, which, by the way, you can actually convert moles of solute to moles of solution, moles of solute to mass of solute and moles of solvent to mass of solvent. You can use this relationship to go from mass of the solution to the moles of the solution. But the mistake that I was telling you not to make is that although for mass and moles, solute plus solvent equals solution, this is not true for volume. So volume of solute plus volume of solvent generally will not equal the volume of the solution. Just something to be aware of. Alright, so in the next video, I'm going to actually walk you through an example of how you fill up a Mudoku table based on some data, and then we're going to start introducing the concentration terms themselves. So see you in the next video.